Today we finally make it back to the Switch 2, and you're going to notice a few things are different. I have now got some software running that shows my bench power supply and my multimeter. And I want to thank, before we get started, JFIXX and CircuitFix. JFIXX for leading me to CircuitFix and offering the video showing how to set these things up. It's been a bit of a learning curve for me, but I've had a lot of help from CircuitFix. He's actually taken the time to do some coding on the software, and it's an incredible thing. I actually have two O1 setups. Both of them are different, but they are both running through OBS right now. It's an amazing software, and I will leave links to the video, and I will leave links to CircuitFix and where you can get your own software. So we'll get on that later, but for right now, let's get back to the Switch 2. So in the previous video, we've tried all sorts of things, and what this is going to boil down to is I have this guy. And if you notice, this guy, yeah, isn't that awful? That is devastating. So I bought this guy, obviously for parts and repair, but the only thing that's wrong with this is the shattered screen. So what we're going to do today is we're going to open them both up, and we're going to do some side-by-side comparisons on a working board and a non-working board as far as like diode readings and power rails and things like that. And we're going to be able to do that with the new software because I want you guys to be able to actually see the difference between the working board and the non-working board. I done a little bit of messing around with my own Nintendo Switch 2, but I want you to be able to see it. So let's jump right into it. By the power of YouTube, let's get this guy broke down. All right, so here we are. We've got our good working board, and we've got the original non-working board. So let me show you real quick. This is how a working board should act when you plug it in. We should get a little bit of amp draw. It'll go up to about 0.1, then it starts dropping down, and then we should see it bottom out at 0. So if I can hold this right, you'll have to excuse me. I had to do some repairs on this thing. Goes to 0.01 and then to 0. Now, when we plug in the non-working board, you're going to see it just sit at 0. And it'll do that indefinitely. In the beginning, when I first started working on this board, I thought that that might be normal because on the original Nintendo Switch and Switch Lite and the OLED, you didn't really get an amp draw. So 0 amps on a board that's not plugged in would be ideal. So first, let's get under the microscope and let's do a little bit of comparison on our chips here. Most notably, I want to check around this guy. Hang on. This is kind of like the M92 on the original Switch. This is kind of our main power delivery system here. So let's do a little bit of testing here. 0.5, ground. Okay, it's our ground. I believe these are our current sense resistors. These are basically just bridges Okay. Ground. All of these. It's our ground leg. Okay. If we come over here to this guy, we're going to find almost identical readings, which for me is a bit strange because just about every single one of these that I've tested for working versus non-working is almost identical. They all seem to have very healthy readings. This inductor looks really bad. Let's see. What's the reading on this one? 0.07. 0.07. Let's see what it reads. Yeah, about the same. Again, we're on the non-working board. Now these chips, these dialogue chips, you might have heard me talking about them in the previous video. These are power management chips as well. And while the numbers, these aren't direct shorts. I think these are low impedance lines because they're pretty much identical. But if you look at the working board, you pretty much have the same readings. They're almost identical. I say almost. There's not that huge of a difference in these. So 0.07, and then ground. And then if we come over here, look at the non-working board, we will see basically 0.07, ground, 0.07. Now I've gone over these. Almost looks like a crack, doesn't it? Is that cracked? Huh. I didn't notice that before. Let me zoom in a little closer. Can't tell if that's just like scratched, or is this guy actually like cracked? Can you see that? All right. What do you test here? Let's try it in resistance. See what we're looking at here. 8.4. Almost 8. Well, it does look like it's cracked. Let's compare it to this one. See what our readings show. Again, in ohms, about the same. So maybe it's just a surface scratch. So let's come over here next to our battery connector. And I want to check around. Let's check around our fuel gauge IC. Okay. Again, that looks normal. Let's compare it to the working one. One. I feel like this resistor here is reading a little different. No, it's the same 0.1, 0.3. Okay, so on the non-working, let's check our connector. 0.5, 0.5, 0.5. That should be ground and ground. 0.5, 0.5, 0.5, ground and ground. Let's check around these little, I'm assuming they're the type of MOSFET. This guy looks a little kind of rough. 0.3, 0.3, 0.3, ground, ground. Doesn't look like a direct short, but let's see what it looks like over here. What are you reading? About the same. Okay. All right. So this is pretty much a reoccurring theme with this guy. Here we have another Max chip. And again, I've tested all of these, and I've tested them over and over again against a working board. And the damnedest thing is they all seem to be reading the exact same. But I wonder if some type of internal failure on our what is that? The CD chip or whatever it is. I guess I got to get used to the CP1, CP10359AT. I've searched for replacement chips for this, and as far as I could tell, they're not readily available, not just yet. If anybody knows how to get a hold of those, let me know. Drop it in the comments, all that good stuff, because I have this feeling that this is going to be our culprit here, this guy right here. If it's anything like M92, then it's prone to failure, because all of our fuses and things like that are good. Now, it could be because this board had water damage, that it could be, you know, something internally going on. So now what we're going to do is we're going to attempt to rebuild one working Nintendo Switch 2 out of the parts that we have. Now I'm taking a bit of a gamble here, assuming that this screen actually works. So what I'm going to do is attempt to put this back together enough to test the working board. Let's hope it's working. I really do hope it's working. But I do want to replace all the components that we have that might actually lead to, because we had corrosion on these ribbon cables. We had a little bit, I think, if I remember right, on the screen connector. It's a no connect. One's a little rough. That one's a no connect. I'm not sure about these two. So those two are tied together. Let's check to see if they have continuity between the two. And they do. Okay, so they connect here and not here. So that's a good sign. Okay, let us hope that this thing is going to work. All right. So we're not going to figure out if it's working if we don't start. Okay, so is this enough back together to get it to power on? Let's find out. And will the screen work? Even bigger question. Again, let's find out. Will you power on? Hey, so I guess the screen might be good. Okay, I'm going to leave it right here. We're going to let it charge, and we'll come right back. Well, it would seem like the seller was telling the truth. And most importantly, now we know this screen does in fact work. So I've got, these are my Joy-Cons. We've got some issues going on with the Joy-Cons that came with the other ones. So let's just see if these work. Okay. Okay. Nice. And it has been reset. We don't have any of our Wi-Fi antennas connected. So let's turn this guy off, finish putting it back together, and we'll go from there. Okay, let's see if it will read a game. And it does. Nice. Okay, let's finish putting it back together. So, while I don't really necessarily consider this a fix, um, I do plan on keeping that motherboard around until we can get a few repair chips in here. I don't know how long it's going to be until somebody like finally gets a hold of some of these things. I don't know if we're going to be able to. I seriously doubt we can get them direct from Nintendo. But again, in the beginning, I told you guys about uh, my new setup and how I've got this software running now for my supply and my meter. I want to thank you, CircuitFix, and I want to thank you, JFIXX, for bringing CircuitFix into light for me, because I had no idea that these things were even around. Um, but thank both of you very much. I'm going to add in the description of the video, I'll add a link to JFIXX's channel and CircuitFix's channel, and I'll add a link to download for CircuitFix's software if you guys want to check it out yourself. JFIXX has an amazing video on that already, so I won't go into details about any of that. Go check his video out. Very much worth it. Okay. I want to thank everybody for joining me today, and the next video, having to deal with this switch too, we're going to see if we can tackle these non-working Joy-Cons. Both of these I've tried on a working switch. Just real quick, I'll show you. So we get just the gray bar, and same on this side, gray bar. So we're going to see if we can get these Joy-Cons repaired. Until then, I want to thank you guys for joining me. I'm very happy to see this guy up and running. There's a little, you could tell that there's a little bit of water damage. There's some light spots inside of the screen. This guy had some serious water damage. I kind of wonder if I ended up with the one that TronicsFix had that got put into the washing machine. But I doubt that. I'm pretty sure he kept his for parts. But anyway, thank you for joining me, and I hope to see you guys again soon in my cave.